Hi, it's time for a music and sound repair video. What we have here just assembled on the workbench is a music and sound model 228. The basic model is a 220, and then if it's got a built-in 3-note chime, it's a 223, and if it has an 8-note built-in chime, it's a 228. This set, here as I can tell, it was made probably sometime in 1978 or so, maybe a little later. And I think it originally probably came out around 1974. It's a very traditional early music and sound set. It's got the super heavy, probably weighs 4 pounds, cast aluminum or some other kind of metal, Zymac or something, front grille, very classy, very traditional music and sound look, fancy scroll work here, cloth grill over the speaker. This is the way a lot of these early sets look, and I don't know exactly because it's not really what I do for a living, but I would imagine this probably costs a lot of money to have made. I don't know, but it's certainly not your typical, early mid-70s plastic faceplate. So we'll put that over there. It is a model that does have, bring it back for a second. It does have a digital clock. There was an earlier version, as near as I can tell, that had an analog clock. Analog clock means it's got hands and numbers, and you tell time with the hands and numbers. Remember those? This is a later one, and it's had a digital clock. And the digital clock is actually just a little module. It's really very independent of everything else. It's got power leads. It's got a power transformer. It's got a little daughter board on the back here with 2 integrated circuits, which I actually didn't look up to see what they were. I think one of them is a flip-flop. I think the other one is a logic gate. Probably has something to do with turning the music on. I didn't play around with it. This set was delivered to me in nearly dead condition. So it's got a 4 7-segment LED display. It's got a red LED here, which is for something, I don't know what exactly. AM and PM it looks like, and buttons to set it, and actually it goes this way. This part of it here, I have a feeling is a pre-made module, probably made by some other company. You can kind of see right down in there where my finger's pointing, there's a circular little black blob. That's an integrated circuit. It's an onboard with a blob over it. So this probably came from some company as a pre-made module, and then Music and Sound maybe made this board to go on the back of it to make it work with the intercom. For its day, this is an 8-note chime module. For when this set came out in the late 70s, and it was probably designed before that, this is quite advanced for the late 70s to have a built-in 8-note chime module. That's why this is a model 228. What's interesting about this board is, this board, I looked up all the integrated circuits on it. When we think chime module in today's more modern designs, you would have a microprocessor that runs a program that contains the chime notes or songs or whatever it plays, and then supporting components to make it all work. This is not like that at all. This is all individual discrete components, and it is, I looked up I think almost all of them. I might have missed one. There's a decade counter, which is what keeps the timing. There's a buffer, there's a logic gate, there's a flip-flop. I believe there's probably a Schmidt trigger in here also to square up the waves, but maybe it's this one and I missed it. I don't think I wrote them all down. There's a little op amp right here. And then the most interesting thing on here is this chip right here. This is an AMS, or American Microsystems. It's a 50245, which I took a little bit of time to try to figure out what it was, the company that made it, because I don't think they're around anymore, and to find out what it was. It is a somewhat different package. It's still a 16-pin DIP package, but it's different. All these other ones are Motorola parts. And this is actually it's a PMOS chip. It's a top octave synthesizer. I have a hard time saying that. Its original purpose or intended use was to use in electronic organs, like the kind you would buy to put in your house. Like that's, I assume, where the tones are generated or stored, but that's the heart of the whole thing. But no microprocessor. This chip, probably impossible to find, or maybe not. The data sheet I found from it was a booklet from American Microsystems that detailed out all of the integrated circuits they had available, and they had a lot. I think the downloadable PDF catalog was over 680 pages long, chock full of parts and application notes and data sheets and things, and this is one of probably several thousand chips in the catalog. So I found that rather interesting. The most other interesting thing on here is you'll see all of these little blue blobs. These are all little tantalum capacitors, referred to as tag tantalums, because they look like little tags, like little, sort of like skin tags. These are notoriously failure prone. Now, it's surprising in this that maybe none of these have exploded, because if you get reverse voltage through one of these, it actually will explode. It will pop on the board and blow itself apart. So that hasn't happened, but that doesn't mean that these are all good. A lot of these fail. These were very, very popular to use back in these times, and part of the job on this will probably be to go through and check them all and replace. If there's a majority of them, or even just some of them that are bad, they probably will all get replaced. So Chime module, 1978, probably before that when it was designed, fairly advanced for its day. Got a lot of screws and knobs and nuts and washers. These things are put together like tanks. You got the big cast aluminum grill. You have all of this folded metal work that makes up the chassis of the unit. You got room control switches here. You've got different function switches here. This one is to tune the radio. When you come right down to it at the end, what you've got here is a chassis that's made up of 3 circuit boards. You've got power supply amplifier board here. You got AM/FM tuner board over here, and down here, this little board is the intercom board. This doesn't consist of much of anything. It's got an LM2900, which is a little amplifier IC, and it's got a relay and supporting components. Very, very simple. So the story behind this unit is the fellow who sent it in, it belongs to his sister. She's lived in the house since this was new, I believe, and recently is like a year ago, they had a big storm with lightning, and there was a lightning event, let's say, and I don't know whether the house got hit or a tree got hit or what the deal was, but after the storm and the lightning, this didn't work anymore. So it was taken out, and there was an attempt to repair it. It was a failed attempt. It wasn't really repairable. Only got it to the point that it kind of sort of turned on. There was no sound from the radio at all. There was a little bit of sound from the Chime module, although it was very heavily distorted, so obviously something's wrong. And everybody, of course, at that point stops trying to work on it because they really don't know what to do with it. There was an assumption, and it was only an assumption, I have a feeling, that the tuner is blown up, which hopefully it's not. Most of the work that was done on it revolves around the amplifier power supply board here, and I'm going to try not to be too harsh with all of this, but we need to talk about it in real terms. So real terms. So first, right off the bat, a set like this is a total pain in the neck to work on, because, and this is if you got one in that was fully original and all of that. One, it's the way the boards are made. Got power supply section here, got amplifier, it's missing its output transistors. I've taken them off for the time being. Got output transistors here. This is all amplifier and a little bit of preamp stuff. There's an op amp here, which is again kind of interesting for its day. It's a plain old fiberglass circuit board. There are no component designations on the surface of the board whatsoever. It's a plain tan fiberglass circuit board. How these boards were actually made in the first place beats the hell out of me. When this was a bare board, when the board was newly made and they began to populate with all the parts, there's nothing to tell you what goes where. So I don't know how it was actually assembled. I'm sure it was assembled by hand, and maybe they had a bunch of people sitting on an assembly line, and Joey there was responsible for putting in the 6 transistors, and Betty Lou next to him was putting in the film caps, and they just knew where to go, or there was a drawing that showed where, but it just is kind of asinine. It just is. And this is 1978. 1978 are not the early days of solid state electronics. It's not 1955. It's 1978. And so how mass produced these things actually were beats the heck out of me. On the other side, which you can kind of see, it's just a copper board. It's not even tin plated. It's just etched copper. There's no tin plating, there's no solder mask, there's no silk screen, there's no nothing. You know, it's like, hey, Bob, run down to Radio Shack and buy some of those kits and some bare boards so we can make some more circuit boards and make intercoms. Really? for 1978, this is like easily like 20 years out of date. And it makes repairing them really, really challenging because you have to keep track of all the details of where everything goes and the orientation of components, because there's nothing here that indicates anything. And it's just a total pain in the neck to work on. However, we can still do it, but it's just a pain in the neck. It's doubly a pain in the neck when you get a board in that someone else has worked on and you don't know exactly everything that was exactly done. So let me get something real quick. Hold on a second. Okay, so here's the note that came along with it from the fella who dropped it off. I replaced the 24 volt and 15 volt regulators. That's here and here. The PNP and NPN power transistors. That's these. And several general purpose transistors, Q2, 4, and 6. I cleaned the pots with deoxit D5. The circuit boards had a lot of flux on them, so I cleaned them with alcohol. The power supply now appears to be okay. The radio doesn't work, and the door chime has low and distorted volume. That was the work that was reported to be done. The output transistors, so this set, surprisingly enough, this uses fairly common output transistors that are still available today. They're commonly available. I'm going to order some from our regular first tier supplier because these two that he chose aren't really the best choice in my opinion. That's probably what he could find. One of the things you should always know is that if you can get the original parts that go into something you're working on or repairing, go with those. Don't go with some generic replacement that seems like maybe it's okay. If you can get the real deal, go with the real deal. And they're commonly available and they're not expensive. They're like $1.50 a piece or $2 or something. So it's not a big deal. The other thing which I find interesting but annoying is that some of the capacitors I think were replaced. So I think this one was replaced and this one and this one and maybe that one. So this one, these lighter blue ones, because this is light blue but this is lighter. This one, this one, this one, these, probably this one, and these darker blue ones down here, I'm not sure exactly, but I think those are original also. Those are all, like this one is dated 1977, this one's dated 1978, this one 77. These are all original. These are all Nichicon capacitors, which are very good quality, but if you figure that, you know, these are 45 years old, and like these are the two power supply capacitors, they need to be replaced. I don't care how they measure or what you think about them. They just typically should be replaced. This one, I think, was replaced. It's an Ideal brand, which I have no idea what that is. And also, it's not really soldered down on sitting on the board properly as it should be. The other thing, the small signal transistors that were replaced, I think were this one, this one, this one, I think. But it's hard to tell because normally what you look for is, and they are the right transistors as far as I know, usually what you look for is you look on the back side of the board and see where the solder obviously has been touched up or redone because it's cleaner, shinier, or whatever. In this case, it's really hard to tell that, so that's a problem. When you get a set in like this that has a failed repair attempt, that can very much color the way you look at what you're going to do. You have to like get over it because it's just like any other broken intercom. You do have to spend a little bit of time and try to sort through what the person before you did to see if they made any, simply put, bonehead mistakes, which does happen. But in this case, it seems like it's probably kind of okay, but not, for a do-it-yourself repair, it's probably not bad. And let's go back to the note. So he rebuilt the power supply. The power supply is this portion of the board up here at the top. It doesn't really consist of very much. You've got 4 diodes down here that build a bridge rectifier. You've got a little ceramic cap here. You've got a resistor, another ceramic cap. This film cap may or may not be, I don't remember from the schematic exactly. There are 2 linear voltage regulator and 2 power supply capacitors. It's very, very simple. It's like the simplest power supply you possibly could have. That was probably not really much at the heart of the problem of why it didn't work altogether. And if it did fail, it most likely was because all of the original parts were 45 years old. And if there was a power surge during a storm, sometimes that's enough to kill components that are already weakened from age. A little bit of work will be done on this to bring it up to what I want it to be. And then these two power transistors, again, not the best choices in my opinion. One of them looks a little questionable and it's supposed to be brand new, so I don't know about that. We'll be ordering the correct ones. And then the other thing is like, okay, beyond that, where do you start? So where I would start, the other thing that it looked like to me is there are 4 little diodes in this group right here. And there are 2 more down here, and these are 1N4148s. They're little quarter-watt diodes. To me, these look like they were replaced. Now, I can't tell based on the soldering. They are a more modern-looking diode than, say, these 3 right here, which I think are original. And also, these are all kind of hanging up off the board. There's a lot of space underneath them, and I don't think, based on how all the other components on this board are placed, that that's the way it would have been made when it was new. So those, I think, were replaced. When you have a set that doesn't do anything at all, it comes as alive because there is voltage, but it doesn't operate really in the way it's supposed to. The first thing you do is you measure voltages. The second thing I always do is I check solid state components. I check diodes, transistors, because those are the kind of components, especially in a power surge situation, that are most likely to fail. You're not really going to have a lot of resistors that are blown up from a power surge sometimes, but it's not that common. And also, if a resistor is blown up, it's going to be burnt black. So it's pretty easy to see. It doesn't mean we're not going to check them at some point, but it's not usually enough to keep a set from working altogether. The first thing I like to do is I pulled out the power transistors to check these. Not happy with what I saw. These voltage regulators are new and they are regulating correctly, so that's okay. 4 diodes that build the bridge rectifier down here, they seem to be okay. I haven't gone through the little small signal transistors yet, but that will happen. But the other thing I like to do is I like to check all the diodes. So these 3 green diodes up here seem to be okay. These 2 down here, one of them is shorted out. And of these 4 in this group, 2 of them are shorted out. Now, if those are brand new, which I think they are, it seems to me that something has happened that caused them to short out. And it probably would be because some other components on the board are drawing too much current through them. And these are only quarter-watt resistors. So it doesn't take much to blow them up. You know, you could take one of these and put it across the 9-volt battery and watch it glow inside, and then it'll burn out. There's work to be done on this. There are parts to order, and the goal here is you have to get something working. That's the goal. That's the first step. One of the rules that you should follow in something like this is there's always an inclination of, well, you got all these old capacitors on here, we're just going to replace all those and see if it's better. That's not the right approach, because every time you change a part, you increase the number of variables in the repair while you're looking to bring it back to life. While this capacitor, these original ones, may be somewhat dodgy, they're probably not open completely or shorted completely. They might be, but usually not so much. They certainly will not be up to what they were supposed to be when they were brand new, but usually it's not enough to cause a board not to work at all. So we're going to leave those for right now, because lots of times people, change out all the capacitors. Why are you going to do that? Well, because they need to be changed, but why are you doing it now? And it's like, they don't always have an answer, but the real answer is, the thing they don't want to say or they don't think about is, because it makes me feel better because like I did something. And you have to not approach it that way, because you're introducing too many variables into the repair, and that makes it more complicated later on sometimes to figure out what's wrong when it doesn't work. So we're going to start off with the basics. I probably will change both of these just because I like a good solid power supply. I don't want a dodgy power supply. You know, I've been doing this for a while. I have a good feeling for how I want to do things. We're going to replace, I have to look on the schematic and make sure these are the correct values of diodes for this board. All of these will get replaced. I'm going to order this little op amp. I'm going to test the transistors. They're probably all fine, but just in case. And I'm going to order the correct pair of output transistors, and hopefully with a little bit of work, we'll be able to bring this board back to life. The nice thing about this design is right here on this board, there are 2 RCA jacks where you could connect in external music sources. So if I can get this board working and use this as a signal source so I know that the board works, then we can address the AM/FM tuner board over here. And once we get that addressed, then we can address if there's anything wrong with the Chime module board, and then we'll put it all back together with its 1 million screws, nuts, and washers, and we should have a working intercom again. It's a somewhat disjointed repair at this point because there's things that I'm not sure about because it's been worked on before, but we'll try not to let that get, we're not going to go down the wrong rabbit hole. It's too simple of a set. Come on, when you look at it, the majority of the set is one board. And a tuner board, and the tuner board is the tuner board. So most of what's on here, there's 2 integrated circuits. There are, and I'll show you. There's the tuner board. So you got variable tuning condenser, you got 2 integrated circuits here. These are standard types of integrated circuit models that are used in AM/FM analog tuners. You've got capacitors. There's one transistor there and one there, and these 2 here and here. These are probably FETs. They're probably low noise FETs, which are really common to use in radio tuners of the day. Hopefully these are good because these are hard to replace nowadays because they're hard to find. And then you've got a bunch of passives, and all of these are all little tuning coils. Those will all be fine. Those never go bad. They might need to be tweaked a little bit. It might be a little bit to tune it up so it tunes better. But other than that, you don't have to worry about it too much. So there's not a lot here to go wrong. It doesn't mean these integrated circuits couldn't be blown up, because they could be, but somehow I doubt it. And then you got this little intercom board, that thing down here. Again, 3 transistors, a little amplifier IC. This is actually an amplifier IC that I keep in stock, because it's used in a lot of NuTone apartment house intercom stuff and door chimes and things like that. So that I have in case it needs to be replaced. But other than that, it's a pretty simple set. You got, 2 boards, the chime module, and a module for a clock. So it's not that big a deal. It's just like you got to stay on track with the repair. So you got to get this working first and then work on the other thing. A little bit of rambling here, but it helps me sometimes to verbally go through the whole thing because it helps sort of quantify what it is I'm going to do and the approach I'm going to take with it. So the next time you see it, it should be playing. Oh, the other thing which I find really cool on this set, I will say this, is like on this board right here, I'll hold this up so you can see. Right here where my finger's pointing, right here. There's a bunch of scribbled initials in pen, I think it's pen and pencil, right there. And it's like BSI MG-2 DC3 CI4, and I assume that those are the people that built the board on the assembly line. And then also, or however it was that they did it, also, if we look over here on the chassis, which will be a little hard to show, right above where my finger is behind the tuning dial cord, there are other initials. There are VP, KD, LA, LA again, BR, and GL. And I assume that those are the initials of the people who built this set. I would also assume that this was probably built in the factory at Music and Sound in Dallas, Texas back in the day. They probably had some kind of facility where it was like many workstations. So I'm sitting here in my workstation, I do my part, I move it on to the next person, and their board comes to me, and I do my part and move it on, and boards keep moving down the assembly line as they get built. And then at some point they go to where boards are put into the chassis, and then somebody does the wire up. And as each person does their part, they initial what they did, because there's always somebody in charge. And that person, if you've got a whole bunch of boards like this, and let's see who we got here. We got BSI, Bobby Scott Ingram. I don't know, making that up. Anyway, if his job was to put in all the little diodes, and all of a sudden at the end of the day, or at the end of the week maybe, there's a whole bunch of boards that don't work because Bobby Scott there put the diodes in backwards, there's going to be hell to pay. Because there's always a manager. And they have to keep on top of what goes on, and they have to know who did it, because if it's not signed off on, then it's going to be like, well, who's doing diodes on Wednesday? And everybody's going to go like this. He did it. And it's just like junior high school. So I find that those are like little clues. They're like hieroglyphics from the Egyptians. They're clues into the past of what happened. And I always find that kind of interesting. So I hope you found this interesting, and maybe for someone it will be helpful. If it is, give it a thumbs up on YouTube, because that helps us a whole bunch. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications. And every time we post a new video, you'll get a notification and you can watch it. I assume this will be part 1. Part 2 will probably be when it plays. And then maybe there'll be a part 3, and who knows, could be a part 4. This could be one hellacious repair. You know, I don't know. But we'll go through it step by step and see what we can do. See ya.